All right, so when we talk about the blood gases and how they're transported, we're going to find that oxygen is the easier one to understand because, as we've said before, oxygen is reversibly bound to the heme unit, the iron-containing unit in hemoglobin. And we know that there's, for every hemoglobin molecule, there are 4 heme units, and from the last section we know that so every hemoglobin molecule is carrying 4 molecules of oxygen. Now, the wording we use is important to note. We say oxygen is carried through the circulatory system reversibly bound to hemoglobin. And so that means it is attached to it, but it will be released. Now, the question is, how tightly is oxygen bound to that hemoglobin? And the answer is like your mama used to say to you, it depends. What does it depend on, right? It depends upon that other gas, CO2. So it depends on the concentration of CO2. Now, what does CO2 do? So you might remember in A&P1, we had talked about how CO2 in the blood is going to dissolve to form carbonic acid, and so it's going to, as the levels of CO2 rise, the blood becomes more acidic. Well, it ends up, as the blood becomes more acidic and CO2 levels rise, oxygen is more easily released. And so we have on this slide that I'm attaching this to, you have some curves, and basically what it's showing is as acidity increases, that means you become lower and lower pH, that correlates to rising CO2. That means that the oxygen that is bound to the hemoglobin is going to be more readily released. Now, when do you have an increase in CO2? When you have an increase in cellular respiration, which means you are using stored energy to do work. So like you're working out, you're on that treadmill going. You need more. You need to release more of the oxygen so you can handle increased cellular respiration. So it's tied to that. The other factor also relates to that is increased body temperature. So increased body temperature, you get hot when you're working out, or I do. Increased body temperature and more acidic, you're more readily going to release the oxygen that is bound to the hemoglobin. Now, that is the easier of the 2 processes. Next, we're going to talk about CO2.